Hi, it is good to have you here once again. This is Powerland Science and Maths TV. If you are new on this channel, I solve mathematics, physics, and chemistry related problems and offer solutions to assignments. Now, if this happens to be part of the content you are interested in, please don't hesitate to stay tuned and you can familiarize yourself with the content on this channel and you can share with others. Now, in this video, we are to find for the derivative of the function f of x with respect to x, and the function is root of x, and we are to use the first principle. Now, the first principle states that dy dx is given by the limit as change in x represented by h approaches to 0 of f of x plus change in x represented by h minus the original f of x, or divided by the change in x represented by h. That should be the dy dx. So what we are going to do here is that already we know our f of x. Now we have to find our f of x plus h. Okay, but first of all, let me be quick to say that to solve this, we need to let y be equal to f of x, meaning that y is the same as f of x. So we know f of x to be root of x. Now let's find f of x plus h. F of x plus h becomes square root of x plus h, and therefore our dy dx becomes limit as h approaches 0 of f of x plus h is square root of x plus h minus the f of x is square root of x, all these divided by h. And so to move further, what I'm going to do is that I'm going to find the conjugate of the numerator, and then multiply the original numerator and the denominator by the conjugate. This is what I mean. The conjugate of root of x plus h minus root of x is simply root of x plus h plus root of x. So what I'm going to do is that I'm going to multiply this function here by root of x plus h plus root of x, all divided by root of x plus h plus root of x. So dy dx becomes equal to limit as h approaches 0 of x plus h, that is square root of x plus h, minus square root of x. I'll multiply this by the conjugate, which is root of x plus h plus root of x, all these divided by the h will also multiply the square root of x plus h plus square root of x. And so dy dx becomes limit as h approaches 0. Now you should know that at the numerator, difference of 2 squared is represented here, because you have root of x plus h minus root of x, then root of x plus h plus root of x. So I can say that this is the same as square root of x plus h all squared minus square root of x also all squared. All these divided by h into bracket square root of x plus h plus root of x. And so this gives limit as h approaches 0. Now the square cancels that and we'll be left with x plus h minus x. All these divided by h into bracket x plus h plus root of x. And so breaking this down, we are going to end up with, let me continue, we are going to end up with limit as h approaches 0 of, we'll be left with h divided by, h is multiplying x square root of x plus h and square root of x. And this gives us, so over here, sorry, this is plus. So over here, what we are going to do is that we are just going to find the limit of this function. And to do that, before we get into that, we realize that this h will cancel that, and so we'll be left with limit as h approaches 0 of 1 on root of x plus h plus root of x. And so dy dx becomes, now I'm just going to find the limit straight away. So wherever I see h, its value becomes 0, and so we will have 1 on square root of x plus 0, which will give us 1 on square root of x plus another root of x, and this will finally give us 1 on 2 root x. And therefore dy dx of the function square root of x from the first principle is given as 1 on 2 root x. Thank you for watching this video, and please don't forget to subscribe to this channel if you haven't. Bye bye.